Hello everyone, this is Edward Doolittle. I'm here with a Math 101 lecture. The topic is Markup and Markdown, which is an application of decimal fractions. And I am using a pre-written note here because for some reason the recording failed. I'm not sure why. Anyway, I went through all of this already, and the recording just disappeared on me. So I'm going to try recording it again, and I'm just going to use the notes that I made already. I hope that you can follow along okay. So an example of markup. Markup is used all the time, say by people in Saskatchewan, when you add sales tax onto something. That marks the price up. So you see a price tag, a certain amount in a store, and we have to pay 11% more than that at the till. And first thing we need to understand is what we mean by percent. And percent is just a fraction. So 11% means 11 over 100. 11 over 100, and you can see that that is like the symbol here. The symbol, there are two zeros and a slash, and that's the two zeros and the slash in the fraction. So that percent symbol just means divide by 100, and all they've done is save drawing one character, drawing the 1. So it's just an abbreviation for divide by 100. That's all that percent really means. All right, so here is how we calculate 11% tax on a $1 purchase. So we have a $1 purchase, and we multiply by 11%. So here I've taken my 11 over 100, and I've converted it into a decimal fraction, and it looks like 0.11 as a decimal. Right, so you type this in your calculator, 11 divided by 100, and you're going to get 0.11. So that's the way you enter it into a calculator. Some calculators have percent buttons, but it's really just a waste of a button on a calculator, I think, because it's such a simple thing to divide by 100. Or dividing by 100 is just moving a decimal point 2 places to the right. So percentage is very simple. I just take my number and I move the decimal point, and I get 0.11. All right, so those are a couple things, a couple ways of converting a percent into a decimal. All right, now I multiply, use my calculator, 1.00 or $1 times 11% gives me 11 cents. And that's how much tax I pay. I take that amount of tax, I add it to the principal, which is the original price, and I get my final cost at the till. So that's $1.11. $1 goes to the retailer, and 11 cents goes to the government. All right, now if my amount was $2 instead of $1, I do the same steps, but just with $2. So $2 times 0.11 or 11% is 22 cents in tax. I add that amount on to my principal. My principal was $2. I add the 22 cents on, and I get a final price of $2.22. All right, so that is the standard two-step method for calculating a final price given a markup, like a tax. There is, though, a one-step operation, which we'll find is quite useful. And so that one-step operation goes like this. I just take $1 and I multiply by this magic number 1.11. 1.11 is two parts. The 1 stands for the principal, and the 0.11 is the markup. And so it's very, very easy to figure out this number in your head. You just take a 1, and then after the decimal, you put the markup as a decimal. And when I do that, I take $1, my original cost, or the cost the price tag in the store. I multiply by this magic factor, 1.11, and I get my final result. And you'll see that that is the same as I got by the two-step method. So this is a one-step calculation for the final amount, which is usually what I'm interested in. If you're a retailer, you may be interested in what the amount of the tax is, this number here. But as a consumer, you're probably more interested in just what do I owe at the till? What's my final number? And so you just multiply by 1.11 to get that number in one step. So again, if the price in the store was $2, the price tag said $2, I multiply that by 1.11 and I get 2.22. So you see, I got that in one step. It's much faster than this two-step calculation. And also, I don't have to write anything down. I don't have to use the memory on my calculator. I don't have to use parentheses or anything like that. I just I obtain the final result in one step. And I use this all the time when I'm calculating with percentages markups. Okay, now it is really important to know this because here's an example from my own personal experience. This example was from when I was a student at the University of Toronto in the Department of Mathematics at the University of Toronto, and they had a computer for sale that I wanted. It was a very high-power Unix computer, and they were selling it for about 10% of its initial cost, or maybe even less than that. I think the thing was it was maybe, I don't know, I'm guessing $30,000 to $50,000 when they originally bought it, and they were going to sell it to me for $1,800 because they couldn't work it, and I knew how. So it was worth it definitely for me. The problem was that after we had made the agreement for me to purchase this computer for $1,800, they talked with the finance people and realized that they had to charge provincial sales tax on top of the $1,800. And in Ontario at the time, that was 7% PST. And I told them, well, I couldn't afford to. I couldn't afford any more than $1,800. It was pretty much, I was a poor student at the time. So I said, that's just my final offer, $1,800. And they said, all right, we will charge you an amount that with the 7% tax makes the final cost to you $1,800. And I said, all right, that's fine. That's fine with me. So how do we do that? Well, we had some mystery amount, and then we mark it up by 7%. That one is for the principal, and the 7% is the markup, and that should give me $1,800. And that means that I can find the amount that they should have charged me by dividing by 1.07. And if you do that, you type this on your calculator, $1,800 divided by 1.07, you're going to get this answer, 1682.24. And this, I believe, is the correct answer. But this is the way most people would do the calculation, which is why finance people at the university were running into trouble. So most people would do the calculation this way. So they would take $1,800, they would find 7% of that, which is 126. They would subtract that, and they would get 1674. Now, is that right? No, it is not right. I can check it. So I'm going to take 1674, and I'm going to find the 7% tax. That's $117.18. I'm going to add that onto the 1674, and I get 1791.18, which is short of the $1,800. There's a $9 difference. So this isn't the right way to do the calculation, even though this is the way most people would do it. The problem is that that the 7% on 1,800 is more than the 7% on 1674. That you are subtracting more than you should. And so if you do the calculation my way, you get 1682.24. Let's see if that's right. I'm going to take 1682.24, find 7% of that. That's 117.76. I add this to the principal, the tax on the principal, and I get exactly $1,800 right on. So my way is right. Everyone else's way is wrong, and you should learn this. It's an important thing for consumers to learn. It's an important part of consumer mathematics, and you should also teach it in schools. Unfortunately, very few people know how to do this correctly, I've noticed. All right, so let's summarize what happened here. I started with an amount 1682.24. I perform the single step markup, and that is by multiplying by 1.07. That gives me $1,800. So if I want to reverse that process, I have to do the inverse operation of the multiplication. So the inverse of multiplication is division, and it's the same number. So instead of multiplying by 1.07 to go backwards this way, I have to divide by 1.07. And so if this is a markup, this process we call reverse markup. So what happened here is that instead of doing a reverse markup, this is a markdown. And it's not the same as reverse markup. So you should know the difference between the markdown and a reverse markup and which one is appropriate. Sometimes one is appropriate, sometimes other is appropriate. So let's see here now. Here's a question. I have $100 in my pocket, and I want to know what is the most expensive thing I can buy in the store that is going to cost me at most $100, including the tax. So remember, when I go to pay at the till, I have to pay the tax as well as the principal. So that tax plus principal has to add up to at most $100. That is an unknown amount that is on the price tag. When I multiply that unknown amount by 1.11 to get my markup, it should be at most $100. So to figure out what this number is here, I'm going to reverse that process, do a reverse markup, divide by 1.11, and I get $90.09. So if I go into a store with $100 in my pocket, and I know that I'm going to pay I'm going to pay 11 cents, pardon me, I'm going to pay 11% in sales tax, then that means that the highest price tag I can purchase is $90.09, and that will lead to a final cost at the till, including tax, of $100 or less. The wrong way to do this is the way that most people do it, and that would be to mark down from $100. 11% of $100 is $11. I subtract that, I mark down, I get 89, and that is no good because say the thing I want to buy is actually $90. My way tells me I can do it. This way tells me I can't do it. So this is wrong, 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 and this is right. Okay, so the big deal here, markdown is different from reverse markup. Now let's look at markdown. Let's take a closer look at markdown. Markdown, suppose I'm in a store and there's a sale, a 20% off sale. I want to figure out what the prices are. So here is the standard way to do a markdown, two-step method. I'm going to take my original price, $1. I'm going to multiply it by 20%. Remember, I just moved the decimal point 2 places, 20. And I get 20 cents of a markdown. So $1 minus, this time, the 20-cent markdown gives me 80 cents. So that's the correct answer. That is a $1 markdown by 20%. However, I can do this faster. I can do this in one step instead of two. And that is just by taking my $1 and multiplying by this magic factor. This you can calculate in your head. It's 1 minus 20%, and that is 0.80. And compare that to the markup calculation. Remember, in the markup, if I was marking something up by 20%, my magic multiplier would be 1.20, and that is just the same as 1 plus 0.20. And here I'm just doing 1 minus 0.20. But it's still an easier calculation than the two-step method, because you can do this simple 1 minus 20% is 80% in your head. And then I do this, $1 times 0.8 is 80, and that compares correctly with that. So there's a one-step method for doing markdown, just as there's a one-step method for doing markup. So here, let's do some calculations in our head. Suppose we are marking down by 5%. What is the magic factor? It is multiplied by 0.95. How do I get that? I take 1 minus 5% is 95%. So that's 100% is 1 minus 5% is 95%. Now with the decimals, you may say, oh my gosh, there's decimals. It's hard to do decimal calculations, but it's not. You just read it as percent. 100% minus 5% is 95%. How hard is that? That's real easy. All right, so I can do this magic factor in my head. What if I want to mark down by 35%? Magic factor is 0.65. And here's the calculation over here, but it's not hard at all. It's 100% minus 35% is 65%. All right, so that's how we find these magic markdown factors, and then you can do the markdown in one step. So suppose I had something that cost $49.99 originally, and I did a markdown of 35%. The resulting price would be, let's do the calculation, $49.99 marked down by 35% would be $32.49. Yeah, that may be off by a penny because stores sometimes round up when they should round down. Anyway, $32.50, $32.49, whatever. And there's penny rounding nowadays anyway, so it's not such a big deal. All right, so that's how you do a one-step markdown. And that's important to know because you may have to do a reverse markdown, just like we did a reverse markup. There is that possibility of reverse markdown. There's also another application of this one-step calculation for markups and markdowns, and that's we can chain them together. So let's take a look at this example. Here I'm at a store. They've got a sale on. I'm marking everything down from the sticker price by 20%. However, I still have to pay 11% tax on the markdown cost. So first I do the markdown, then I do the markup. And so I try to make this calculation as painless as possible. The first step, I do the markdown in a one-step calculation. I multiply by my magic markdown factor, 0.80. Then I do my markup in one step. I multiply by my magic markup factor, 1.11. And so if I do the first step, $100 times 0.8 is $80. Then I do the markup for tax, and I get $88.80, including tax. That is still a two-step process. For there's two factors happening here: a markdown factor and a markup factor. But one very nice thing about this way of calculating is that I can chain these together into a single magic factor. So I take this number here, 0.8, and I multiply by this number here, 1.11, and I'm going to get this magic number, 0.888, and that is my single step method of getting from the original price, sticker price, to the amount that I pay at the till. Right. And as always, these single steppers are handy because I can use them to reverse the process. So now let's take a look at a more realistic situation or another different situation, and that's if there's $100 in my pocket, and I have this the situation where there's a 20% markdown, but I still have to pay tax on it, and I want to know what is the highest sticker price that I can purchase in this store. This huge sale. I've got $100 burning a hole in my pocket. I want to spend as much of it as I can in the store. What is the highest sticker price? Well, that is an unknown, question mark. But I take that unknown and I multiply by 0.888, my magic factor, and I should get $100. So to figure out what this original unknown was, I reverse that process. And the reverse of multiplication is division. That's actually, technically, it's called an inverse operation. And so I take $100, I divide by 0.888, the magic factor, and I get 112.61. That is the maximum sticker price that I can pay. And you can verify that. You can verify that if I have a sticker price of 112.61, I find my 80% markdown. That's a 20% markdown is multiplied by 0.8. Then I have an 11% markup for the tax, and we should be close to, if not exactly right on, to $100. Right. So this 61. This method can solve problems that you would be flummoxed otherwise, and you may even get the wrong answers if you just use your your experience, because most people do this wrong. They learn to do it wrong, and then they do it wrong. All right, so I give myself a check mark here. Check mark, because I'm right again. Okay, let's just do a quick summary of what these look like. A markup is I multiply by a factor like this. That's 11% markup. A markdown is I multiply by a factor less than 1. Reverse markup is where I divide by my markup factor, and a reverse markdown is where I divide by my markdown factor. All right, so that is it for this topic. There are some examples in the textbook, questions that you could do related to markup and markdown, and chaining together markdowns and so on. All right, that's it. So sorry I had to re-record this video. I don't know what happened. Anyway, I hope that this is now going to record properly. So let's check it out. Bye.